Find the least common multiple here for number 7 of x squared minus 7x plus 6 and x squared plus 3x minus 4. Again, first thing we need to do is write them in factored form. Least common multiple means the times the smallest thing that we can multiply to get to, so we need factors because factors are the things that we multiply. So I need to multiply to 6, add to 7, minus 6, minus 1. And I need to multiply to 4, subtract to 3. If you're not sure, okay, take a second to FOIL those. Now I'm going to put these together. I'm going to make an x minus 6 column and an x minus 1 column. Then I'm going to make an x plus 4 column in my second row for my second polynomial and an x minus 1 column. Now I pick the most times that they occur in any individual polynomial. So the most that x minus 6 occurs is once. The most that x minus 1 occurs is once, even though it's in both. And the most that x plus 4 occurs is once. Guys, when we find least common multiple, what we're really finding is our least common denominator. So if those were our denominators, what would our common denominator be? Okay, your least common denominator is your least common multiples of your denominators. Same idea here in number 8. A lot of you forgot about factoring by grouping. Anytime that we have 4 terms and we can't put any of them together, that's going to be our starting place. So we're going to start off with factoring out of the first 2 terms. I have a common x squared. And if I take an x squared out, I'm left with x minus 1. My second 2 terms, I don't have anything common except 1. Okay, 1 is always our common factor. If there isn't anything else, it's just a 1. And that's by using these 2 together. We do 2 at a time. Now I check and compare. Is there anything common between these 2 terms? My x minus 1. So I factor out my x minus 1 and again multiply by whatever's left. X squared plus 1. And I can't factor that any further. X squared plus 1 would be imaginary roots. So we leave it just like that. X squared minus 1, however, is a difference of squares. Minus 1 plus 1. So I'm going to make my columns for my first polynomial here. X minus 1, x squared plus 1. For my second polynomial, I put an x minus 1 in my column, and I put an x plus 1 in its own column. I take the most times they occur, which is an x minus 1, just once, even though it's in both, x squared plus 1, and x plus 1. And this right here is my least common multiple. Simplifying a sum. Okay, now that we're adding and subtracting, this is when we need a common denominator. We need our LCD here. So factor difference of squares here, so m minus 9 is m plus 9. Common denominator, okay, if we use the same idea, I'm going to take m plus 9 in a column, and then I have an m minus 9, m plus 9 column. So my common denominator is m plus 9, m minus 9. I need to make my denominators match. If I look here, I have the m plus 9. I don't have the m minus 9, so I need to multiply by m minus 9. And whatever I do to one part of my fraction, I have to do to the other, top and bottom. In my second term here, I have the m minus 9, I have the m plus 9, so there's nothing that I need to do. Now, I'm going to rewrite this. And it's over my least common denominator, plus 5 over my least common denominator. Once I have a common denominator, I can rewrite it as one fraction. Okay, I just write everything over my common denominator. Here I'm going to simplify just a little bit by distributing. I'm going to have 4m minus 36. My sign is plus, which means I'm going to add here. A lot of you multiplied there, but we are still adding. So combine your like terms. 4m minus 31 over that common denominator. M plus 9, m minus 9. Some of you had m squared minus 81. That would have worked as well. Restrictions here. M cannot equal plus or minus 9. Same idea in 10. It's a good idea too. Don't have to, but you can factor the numerator too just to see if it simplifies it all. So here, multiply to 10, add to 7x plus 5, or a plus 5, sorry, times a plus 2. Guys, I don't really care what variable you use as long as you're consistent through the problem. In our denominator, multiply to 5, subtract to 2, I'd have a plus 5, a minus 3. So we can see here that this simplifies. Plus 5 and a plus 5 cancels. So what I really have is a plus 2 over a minus 3 plus 10 over a minus 3. I already have a common denominator, so I can add my numerators. And again, my operation is adding. So I add those numerators, combine my like terms, and I get a plus 12 over a minus 3. A cannot equal negative 5 or 3. Let's say, though, that you didn't simplify first. Okay, let's say you didn't recognize that there were things that we could have simplified out of there. Okay, we can check our common denominator. Again, our denominator we have to factor regardless to get that common denominator. So right now, I have an a plus 3 times an a minus 3 and an a minus 3, which means my common denominator is a plus 5, a minus 3. I already have the plus 5 and the minus 3 in my first term. In my second, I have the minus 3, but I'm missing the a plus 5. And again, we have to keep these equivalent. So whatever we do to the denominator, we've got to do to the numerator. Have to keep them equivalent. A squared plus 7a plus 10 over our LCD plus 10 times a plus 5 over our LCD, which means we can write this all as one fraction over a common denominator. A squared plus 7a plus 10 plus, I'm going to distribute here, 10a plus 50. Combine your like terms. I'm going to move down here. A squared plus 17a plus 60 over, I'm going to rewrite my common denominator. Last step is we always want to check and see if we can simplify it all. Numerator simplifies. Plus 12 plus 5. That's how we get to 60 and add to 17. Again, over a plus 5a minus 3. When we have common factors, but only if it's written as complete multiplication can they simplify out. We end up with a plus 12 over a minus 3. Again, a cannot equal negative 5 or 3. So it does not matter if you recognize to simplify first and something simplifies out, or you can do it at the end. Sometimes it won't. Sometimes we can't factor this. Sometimes we factor it and nothing simplifies. That's okay, but we always need to check and see just in case. Number 11 here, same idea. We are going to simplify what we can and go from there. Multiply to 24, add to 10, minus 6, and minus 4. Multiply to 42, add to negative 13. So we're going to add up to, multiply to 42, add to 13, minus 6, minus 7. So again, here we can simplify our n minus 6's. We wouldn't have to. We can work it out the other way as well, and I will. But just to show you here, we'd have n minus 4 over n minus 7 minus 9 over n minus 7. Our denominators here are already the same. So we can rewrite this as n minus 4 minus 9. Just combine those numerators exactly as written over n minus 7. Over that common denominator, we get n minus 13 over n minus 7. N cannot equal 1 or 7. Okay, the other way we could have done this is, let's say we didn't simplify here. Let's say we didn't recognize this and didn't simplify those first. Okay, we could have found our common denominator, n minus 1, n minus 7, n minus 7, means our common denominator, n minus 1, n minus 7. The most time your prime factors occur in any expression. Now, my first expression has the minus 1 and the minus 7, so I don't change my numerator at all. Sorry, these are 6's. Minus my second expression has the 7 but is missing the 6. Whatever I multiply the bottom by, I have to multiply the top by here. So I have 9 times n minus 6 over that common denominator. Now, I'm going to go ahead and simplify this. I can write it as one fraction because my denominators are the same. So, n minus 6 times n minus 7. In my denominator, my numerator, I have n squared minus 10n plus 24 minus 9 times n minus 6. I'm going to distribute, and the reason that I didn't do it earlier is because I wanted you guys to see a little bit easier how we have this minus 9 right here, and we need to distribute the minus with our 9. Sign goes with the number. So when we do that, we have n squared minus 10n plus 24 minus 9n plus 54 over our common denominator, n minus 6, n minus 7. Combine your like terms, n squared minus 19n plus 78 over n minus 6, n minus 7. Our numerator, we can check for factors here. Things that multiply to 78, add to 16, n minus 6, n minus 13 over n minus 6, n minus 7. Again, 13 times 6 is 78. Add the two together, we get negative 19, so we're good there. Check to see if we simplify, and we're going to end up with n minus 13 over n minus 7. N, again, cannot equal 6 or 7. So we ended up getting the same answer either way. So it doesn't matter if you recognized right away that n minus 6 divides out, or if you checked at the end. As long as you simplify it, it doesn't matter.